Cognitive load theory, developed by John Sweller, explains how our brains handle information and why learning can sometimes feel overwhelming. It revolves around the idea that our working memory has a limited capacity, and when too much information is presented at once, our ability to process, retain, and understand it diminishes. The three types of cognitive load. 1. Intrinsic load, the complexity of the information itself. Some topics are inherently more difficult, like advanced mathematics versus simple addition. 2. Extraneous load, unnecessary distractions that hinder learning, such as poorly structured content, irrelevant details, or overwhelming visual clutter. 3. Germane load, the effort required to organize and integrate new knowledge, making it meaningful and connected to what we already know. When cognitive load is too high, it leads to frustration, mistakes, and slower learning. Imagine trying to memorize a complex set of instructions while also handling multiple distractions. Your brain struggles to filter relevant information, resulting in mental fatigue. How cognitive load impacts learning. When we learn something new, our brains process and store information in working memory before transferring it to long-term memory. But working memory is incredibly limited. It can only hold about 4 to 7 pieces of information at any given time. If we overload this system, information becomes difficult to absorb, leading to cognitive overload. Think of it like juggling too many balls at once. The more elements competing for attention, the higher the chance of dropping something. This is why structured learning environments are essential. If information is presented in a clear, logical way, learners experience less extraneous load and can focus more on integrating new knowledge into their existing understanding. Practical applications of cognitive load theory. Education. Teachers simplify complex lessons by breaking them into smaller steps, using visuals, and reducing distractions. Design and UX. Websites, apps, and instructional materials prioritize simplicity, avoiding unnecessary cognitive strain. Presentations and content creation. A well-organized, visually clear format ensures that audiences absorb information without feeling overwhelmed. By applying cognitive load theory, we create environments where learning is smoother, information sticks better, and mental exhaustion is minimized. Strategies to reduce cognitive load. 1. Chunking information. Breaking information into manageable pieces improves retention. Instead of trying to memorize an entire textbook chapter, focusing on smaller sections helps learners process details more effectively. 2. Visual aids. Diagrams, charts, and videos help reduce extraneous load by simplifying complex concepts visually rather than relying solely on text. 3. Minimizing distractions. Background noise, unnecessary visual clutter, and redundant information can increase extraneous load. Streamlining content ensures focus remains on relevant details. 4. Worked examples. Step-by-step demonstrations clarify concepts by reducing the burden on working memory. This technique is widely used in problem-solving tasks, such as math and programming exercises. 5. Scaffolding. Gradually increasing difficulty allows learners to build knowledge without feeling overwhelmed. Early guidance helps them navigate complexity before they're required to solve problems independently. Understanding and applying cognitive load theory improves learning efficiency, making knowledge easier to absorb, process, and retain.